The ribbon and paddle blender, that's the most commonly used blender for solids. So U-shaped horizontal trough containing a rotating double helical ribbon or paddle agitator. What you see on the right in the image is basically a double helical ribbon. There is a close clearance between the vessel wall and the agitator. So typically the clearance between the agitator and the vessel wall, in this case, as you can see, is only 3 to 6 millimeters. The charging of the material happens through a top nozzles which are located on top and discharges through a bottom wall. As I said, the working volumes here, in any blender will be less, solid blender will be less than the gross volume. So this blender can be used at capacities ranging from 40 to 70% of the total volumetric capacity. Blending time is 15 to 20 minutes. Blending homogeneity can be anywhere between 90 to 95%. The specific power consumption would be 5 to 12 kilowatt per meter cube. Ribbons are used when you have free flowing and cohesive products. Paddles are suitable for wet and heavy materials. Refractories, you use paddle blenders. Just that the construction of those paddle blenders are a little different from what is used in the chemical or the food industry. And ribbon and paddle blenders are also available, in the vertical configurations. The most common configuration is horizontal, but you have them available in the vertical configuration as well. So continuing with the fluidization type of blender, or the plowshare mixer. Now, as you can see in the image, the mixing element is a plow-shaped, element. You also see a set of blades, 4 blades. These are typically the chopper blades we have, which disintegrate the lumps and the agglomerates in the mass. In the top, you see that there is a small nozzle which is projecting inside. That is basically for addition of the liquids. So the plowshare mixer is suitable not just for solid blending, but it is also suitable for blending solids with liquid. It is suitable for slurry applications, and it is very good at handling a broad range of material densities, viscosities, and characteristics. So the plowshare mixer operates on the principle of a mechanically generated fluid bed with a 3-dimensional movement of product. There is a cylindrical drum containing plow-shaped mixing elements which are mounted on a horizontal shaft, as can be seen in the photograph. It may be fitted with high-speed chopper units for applications which require breakdown of lumps or when mixer is to be used for wet granulation. The working volume ranges from 30 to 70% of the total volume of the equipment. The tip speed or the peripheral speed of the plow is more than 200 meters per minute, and that is required so that you get fluidizing action. The big advantage of using a plowshare mixer is that you can have product combinations with ratios as high as 1:20,000. So there is one ingredient which is 20,000 parts, and there is another ingredient which is just 1,000 part, and still you can do a good mix in a plowshare mixer. It mixes in a very short period of time. That is, within 5 minutes, you can easily achieve 95 to 98% homogeneity. It is capable of handling viscosities up to 6 lakh centipoise. Now that it has so many features and is capable of doing so many things, it is high on power. So specific power for the plowshare mixer is generally in the range of 30 to 40 kilowatt per meter cube. Again, in the refractory applications at our Katni unit, we do have a plowshare mixer. And in our case, the plowshare mixer is designed to ensure that there is no reduction in particle size. And that is the reason why our mixer doesn't require choppers. So besides ensuring that the plows don't cause any disintegration of particles, we also don't require any choppers because we don't need to break down the particles or disintegrate any agglomerates or lumps. A vertical cone screw blender, again, a convective blender working on the principle of convective motion. So here we have a vertical cone screw blender. It consists of a conical shaped vessel with a screw that rotates about its own axis while also orbiting around the periphery of the vessel. So it's basically an orbiting screw which orbits around the periphery of the vessel. The drive system generally consists of two motors, one for rotation of the main drive and the other one for the rotation of the screw. The advantage of this kind of an equipment is that it can operate with batches, as low as 10% of the volume up to 100% of the capacity, just because it's a vertical configuration. Another advantage is 100% material discharge, and the mixing times are around 10 to 15 minutes. The next kind of a mixer, again, we know that this is being used at Nagpur and as well as Katni. It's the twin shaft paddle blender. And in this case, we have paddles which are mounted horizontally in a W-shaped trough. And there is an overlapping motion, and the paddle design facilitates rapid fluidization and ensures excellent movement of particles. So just like the Plowshare Mixer, the twin shaft paddle blender is also working on the principle of fluidization. So the counter rotating paddles lift the particles in the center of the mixer in the fluidized zone where mixing takes place in a state of weightlessness. When you fluidize, you experience a state of weightlessness, and that's how mixing takes place. Normal working volume is about 25% of the total volume, and the range of operation, this is the only mixer where you can actually fill it up above the rated capacity, and 40 to 140% of the rated volumes can be handled by these kind of mixers. The peripheral speed here is in excess of 100 meters per minute. In some cases, mixing times as low as 1 minute are possible. A mixing homogeneity of 98 to 99% is achievable. And you can have a choice of discharge walls. You can have the half Bombay door type wall, the spherical disc wall. These equipment, like the Plowshare Mixer, can also be fitted with high-speed choppers if the lumps or agglomerates are to be broken. Okay. Coming to selection of a solid mixer, this is a classic example, how the different material properties and the characteristics are to be considered, as well as the equipment design and the limitations. Say, for example, when you're talking about free-flowing materials, okay, all the kinds of equipment that we discussed, the plow, the double paddle, the ribbon paddle, or the tumbling blender, they're all possible. Let's look at some specific parameters. Like the tumbling blender, as we said, you can't use it for large volumes. So the capacities are limited to less than 2 meter cube. Whereas the other equipment, well, you can build equipment up to 40, 50 meter cube. Talking about the operational speeds, now the plow works at the highest operational speed, around 3 meters per second and higher than that. The ribbon generally operates at a lower speed. Now, in the case of refractory materials, the speed, the higher the speed, the higher the abrasion and the wear. Okay? And these are factors which are which are to be considered while designing the equipment. We talked about providing high-speed intensifier bars or lump breakers. The power consumption could be different. Like a tumbling blender or a gravity blender has typically a power of less than 10 kilowatt per meter cube of product. And in comparison, if you look at plow, the plow could have as high as 40 kilowatt per meter cube of product. Okay. Mixing time, double paddle less than 1 minute, tumbling blender 5 to 15 minutes. Okay. And then finally, aspects such as product discharge. So tumbling blender, you have an advantage, you have almost 100% product discharge. You can't get 100% product discharge in a plow mixer. So when we are selecting a mixer or a blender, we need to look at all of these factors and then make a choice which is most appropriate.